let's start with the basics. Let's start with the basics. What is scientific notation? What is decimal notation? So, Sci note is what I call scientific notation.
Oh my god.
That is going to be some number times 10 to a power. So, a couple things to make note of. First thing to make note of is you are always going to have this here. You are always going to have times 10 to a power. Now that A value, that number in front, what does that have to be between? It needs to be between 1 and 2. Actually, it could be equal to 1, but it needs to be less than 10. So it could be something like 5.8, but it could not be something like 0.58, because that is less than 1. And it couldn't be 58, because that's greater than 10. So that's the basic scientific notation. We typically use this for very large numbers or very tiny numbers. Okay? The next thing, decimal notation. I'm not going to really write anything about that except is scientific notation expanded out. So it's those really long numbers or those really tiny numbers. Okay? But they're the same thing. They're just using different forms. Okay? So, couple things to make note of. First thing, if your exponent is positive, that means it's going to be a very big number. If that exponent is negative, it's going to be a very small number. Okay? Now, if a number is big, which way are we going to go, to the left or to the right? To the right. If a number is small, which way are we going to go? To the left. Okay? Moving that decimal point. Okay? So let's go ahead and get started on just a couple of problems. If I give you a number like go ahead and expand both of these out on your own. On your own. Amber, yes. 100% done. Very good. Thank you. Hey, Amber. In the middle of the workshop. Well, because you don't understand the scientific notation, it's all red, so I'd probably push that. Just click the problem, you should be going. Go here, go back to your video. When you I'm in a workshop right now, so it's going to be a while. Figure it out. Self-directed learning. I don't know either. I'm not a Khan Academy technician. It's negative, so what is that going to do? Big number or small number? Excellent. Okay, yeah, let's look at this together. So this first thing I notice about this is that this is a negative exponent. So is that going to be a big number or a small number?
Small.
Small. So I'm going to take my decimal and do what with it? I'm going to move it to make it a smaller number or to the left. So I'm going to go 1, 2, 3, 4, 5, 6. There's my new decimal point. And what do I do with these little hoops?
Put the zeros.
Yep, just put zeros there. So I could leave it like that, or I could kind of clean it up a little bit. So this is basically this right here. Really tiny number. Now, as opposed to this, it's only a small change. This turned into a positive, but it's the
it's gonna make it a larger number.
It's gonna make it a larger number. So I'm gonna go 4.8. 1, 2, 3, 4, 5, 6. What do I do with these little hoops again?
You add 5 zeros.
Just add the zeros. And I can double check and say, alright, this is a really big number, and I know that's right because this is positive. This is negative, and I got a really small number, so I know that I'm on the right track. The biggest mistake people make is they just go too fast. You just want to slow down. Make sure you count correctly. Now, a lot of times, those are just your basic ones. I think most of us can handle that. Sometimes you're going to have calculations to do. So, for example, have you guys started periodic table in Miss Filial's class?
No.
You're about to next semester.
Her.
Okay. Well, you will. You'll definitely in Miss Rankin's class. So, like for example, let me tell you this: an atom has 88 neutrons, and a neutron weighs this weight. Okay, milligrams.
Lord, that's a small one.
It's super small. Yeah, think how small an atom is. Super small, right? So every neutron weighs this much. And if I say, how much do all the neutrons weigh together, what would you do?
What's that 88 to that?
Yeah, we would take each neutron and that, we could add it up, or we just multiply and make it faster. So that's 88 times 4.2 times 10 to the negative 20. Now there's two ways to do this. You could expand this out and then put that large decimal notation expanded number in your calculator, but I don't like that because it's going to be really easy to like forget a zero or mess up. So what I would do is I'd put this exact thing into my calculator. So I would do 88 times, and here's the thing about scientific notation, it's like a fraction. What do you always put around a fraction?
Quotation.
Yeah, parentheses.
Quotation.
So I do 4.2 times 10 to the negative 20. Go ahead and do that in your calculator. Tell me what you get.
3.69.
3.69.
6.
6.
Then it has this E.
E. Okay.
Negative 18.
Negative 18. Okay, so the calculator gives you this. And the question then becomes, well, what in the world is this E?
Yeah.
Okay? The calculator, that's just simply the calculator's way of saying times 10. So what this is really saying,
Okay.
now I will not accept this, and neither will the state test people. They don't want to see that E. It's just a formatting thing, but it's easy to fix. All you got to do is rewrite it like this: 3.696 times 10 to negative 18.
Thank you.
That's all you got to do. So whether it's a word problem, a real life problem, or whether it's like your scaffolding where it's just questions, same thing.
Okay.
Yeah.
I thought the even exponent.
It does. So this is the exponent of negative 18. So it's this times 10 to the exponent negative 18. Now, just to clarify one more thing, if I gave you a problem like 2.1 times 10 to the negative 18 over 5.7 times 10 to the 7th, how would you solve that in your calculator? What would you do?
Put the first one in parentheses and then
Put this first one in parentheses, so I put it in here. Then I would do the division sign, and then I can't forget, I gotta have the other parentheses right here. And then when I get an answer, blah, 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 blah,
have the E.
it'll have an E, and it'll have some exponent. So I'm gonna put the answer times 10 to this exponent right here. The two big things that people always mess up on, they need to slow down when they're making their moves, and make sure that the numbers are always between 1 and 10. So, let's do two more quick examples.
Wait, what do you mean between 1 and 10?
So, let me ask you a question. Is this in proper scientific notation?
No.
Why?
Because it's not a decimal between 1 and 3.
Exactly. So if I told you to make this in a proper decimal notation
Okay.
or scientific notation, what would we do?
A 1.3.
Yeah, we need it to be 1.3. Now the one thing is, this is it can get tricky when you have a lot of negatives and positives. So this is what I would suggest. I would take this and figure out what they're trying to do. So right now the decimal is here, right? Let's move it to the left, make it small. 4. So it's 1, 2, 3, 4. So this right here is the original number they're messing with. This is what they really want to change. So how would I make, and that's what I would always do, I'd make it into the number they want, and now how would we change it to the proper way? We'd go 1, 2, 3. And why did I choose it to go here versus here or here?
Because it's greater than 10.
Now we got to be between 1 and 10. So this is 1.3 times 10 to the 1, 2, 3. Is that right?
Mm-hmm.
What do I need to do? This is a small number. So what should this be?
Oh, negative 3.
Negative 3. So this is the proper way.
Mm-hmm.
Let's do another one. Just make sure we're on the same page. Okay. Is this in proper scientific notation?
Yes.
I hear yes, I hear no. Why? I'm going to say no.
It's
Why?
less than 1.
It's less than 1. And we got to be between 1 and 10. So it can't be less than 1, and it can't be greater than 10. So I got to make this into what? I need to move it here. So it's 2.6. So what do I always do? I want to figure out the original number. So what this student made the mistake of doing is 0.26. They move it 1, 2, 3, 4, 5, 6. This is the original number, right here. And I want it to be here, right?
Mm-hmm.
So how'd they get that? They went 1, 2, 3, 4, 5. So what they should have done is 2.6 times 10. And is that positive or negative 5?
Negative.
This is
Oh,
a
that would be
big
positive.
number.
Positive.
Positive 5. This is the one tricky thing, and I would say what I want you to do is when they try to, there are some problems where they're asking you to correct, go slow. You guys have any more questions of me? Okay, very good. Let's go ahead and turn it off.